Let me discuss other problem, projection of solids. In the previous topics, in the previous units, what we had been discussed about the orthographic projection principle, and we started the points and lines, then planes. So the next higher end in the same series, it is the solids. So what are the difference from planes to the solids? Okay, let me write just topic name, orthographic projection of solids. So there is a link from planes to solids. So already in the earlier discussion we have started our basic understanding from the points, then we are extended study to lines. So set of the points is nothing but a line. The shortest distance between the 2 points is a straight line. So after that we are further extended the same principles to make understand the projections about the planes. So the connectivity from the lines to the planes is nothing but area bounded by the planes. So similarly we have the connection between the planes to the solids. Okay? The rules are same. So what are the orthographic projections? Nothing but we are assuming a body, the projecting such that the ray evolved from the object and meets the reference plane orthographically, that means 90 degrees. So where it meets, it leaves in the respective projection. If we join all the set of points, we can able to get the respective profile shape. The same here also, whenever the projections mean vertical plane projection, that is the front view, and horizontal plane projection, the top view to be produced. But the change, there is a change in the object instead of the planes. Now we have to develop with respective solids. So before moving to the actual problems, let me try to understand what is meant by solid. The solid is nothing but, as everyone aware, it is a three-dimensional object. So the connection we are speaking from the planes to the solid, it is nothing but value bounded by the planes. Suppose simple example, a cuboid, or that is a cube we can take. Everyone knows how many surfaces are having a cube? 6 surfaces. If I just observe, or you can imagine how the cube is, all the 6 surfaces are the squares. That means if you are taking a square plane, we place as the bottom one of the point, and all the 4 sides as the vertical, and you can close the 6th one as the top one. So you can able to bound the value by placing the all 6 squares together, which leads a solid the name as a cube. Okay, the same thing we can try to understand the other solids we are having. Clear? So overall you have to just make a point with that one. Solid is nothing but 3-dimensional object which having the 3D. After that, value bounded by planes. So overall we can classify the solids into different classification. One is regular, polyhedrons. When we are speaking regular, automatically we are giving the chance to irregular. So other classification we can say it is irregular polyhedrons. These are basically the first one, the second one, the third one is nothing but other forms of the solids. In this one, come to the regular polyhedrons. So if the polyhedrons is nothing but a Latin name, so which generated by coining the word poly and hedrons. Poly mean many, hedrons mean surfaces. So that is nothing but, just now as spoke, it is value bounded by many surfaces together. So that is a polyhedron. So once we are cutting this polyhedron, we are considering all the planes should be regular shape. Regular mean all the sides must be equal in length and included angle between side to side also same. So then we can say is a regular polyhedrons. Irregular mean polyhedrons, again we are combining the value together by placing the plane figures, but those are not to be a regular shape. So that is the difference from here to here. So now coming to just take a common example in each case. So after that we will discuss one by one the solid. Coming to the regular polyhedrons. Poly mean whatever the surfaces we are considering, all the surfaces to be same shape. Just now I taken a simple example, a cube. Our cube, every surface is a square. That means every square is nothing but a regular plane. The value bounded by all the regular planes is said to be irregular polyhedron. In such that one example we can consider a cube. The cube is nothing but base is a square. After that, all the lateral surfaces, whatever we are keeping also squares, and the top also in the squares. Since it is a 6 surfaces we are using, other name of the cube is hexahedron. Hexa means 6 surfaces together we are forming, so that's why it's cube. In the same series, another example we can take tetrahedron. What is meant by tetra? Anyone? It is nothing but 4. Hedron is the 4, tetra is the 4, hedron again surfaces. The 4 surfaces forms together a value. So that is known as a tetrahedron. These are, all the 4 are equilateral triangles. That means the bottom base is a triangle and connecting with each side is a triangle. Again connected to this edge also a triangle and connected to the behind surface also triangle. If I am placing all the 4 equilateral triangles together such that it makes a certain value, so then that object is known as a tetrahedron. So other way, very rarely asking, but better to know that part also. So that is the octahedron. Again hedron are the surfaces. Octa will mean already everyone, that is the number 8. So if you have 8 areas, planes together, so these are also equilateral triangles. So how the shape you can imagine here. In the bottom surface, the middle portion like a square, connecting this one. That means this side, this side, this side, this side. All the 4 sides constitute an equilateral triangle. Similarly, on the above side also, those are connected by the equilateral triangle. So all edges, each, whatever the bottom, we are having the middle portion as a square shape. The bottom side, each side constitute an equilateral triangle. The top side also have the equilateral triangle. So then all together 8 equilateral triangle forms a polyhedron. After so many we are having, but as the examination point of view or in our subject point of view, we are not considering that much. Okay, decahedron, dodecahedron. So all those are the other forms of comes under the regular polyhedrons. So this is got the name regular polyhedron since all the surfaces should be same. So which have the regular shape. Mostly as a subject point of view in the examination, please everyone to make, these are the very important. Cube, you too understood, and also tetrahedron also how the shape should be. So in either the cases, even the solids mean how many we are having the 3-dimensional object, but to specify description of the object, a single dimension is sufficient to identify. Why? Because being the regular shape, all the edges must be same. If the square, all the square, if the square side would have given, it is asked to cube, nothing but every edge should be in the same length. If it is a tetrahedron, one edge may be mentioned, it understood that every edge should measure in the same length. So that's why even it represents of the 3-dimensional. So one dimension is nothing but equal to the second and third dimensional. So that's why to define a single dimension sufficient to describe the respective object. Clear? So this one is respect to the regular. Coming to the irregular. Irregular means again it is a value bounded by the polyhedron itself, but come to the irregular. So what the difference you can find? Let me discuss about the irregular. Irregular polyhedrons. Again we have the okay, in the irregular polyhedron again we have the sub classification. So one we have the prisms. Okay, and the second one is the pyramids. In the prisms, what the quality mean? The base and face, that means the bottom one and top one are any regular polygon. All the lateral surface is the rectangular surfaces. In the pyramid, we are having the base can be any regular polygon and top we are having the only single apex. So it will be better to understand, take the simple object, the base is the square shape. Let's take. In the prisms, what the quality we are having mean? the base may be considered a square. Then on the top portion, face also should be a square. That is the condition here. Okay? So this is a prism. Compared to the pyramid, what the difference? Same shape I may take here. Same shape of the square I may consider here. But top we are having only common single point. So this is the difference from pyramid to pyramid. So these are named behind. Any prism named behind base shape. In either the case, either this also same name and this also same name. Suppose I taken here, what is the base shape we are having? It is of the square, so it is known as the square prism. Since base shape is a square, it is known as a square pyramid. If the base may be triangle, so then it is a triangle prism. If the base is a pentagon, then it is a pentagonal pyramid. If it is hexagon, hexagonal prism. If it may be rectangle, rectangular pyramid. So like that, depends on the base, how the shape it is. So based on that one, these are named. For the examples under the prism, you can write triangular prism, square prism, pentagonal prism, hexagonal prism. So like that, so on. Similarly, what the examples I can write in the case of the pyramid? Again same. Triangular pyramid, square pyramid, pentagonal pyramid, hexagonal pyramid, and so on, as many polygons exist. Clear? So that's why you have to clearly keep in mind irregular polyhedrons mean comes under the again subclassification as the prisms and the pyramids. So why we are coming the irregular mean? Coming to the base and face is same, but the lateral surfaces are the rectangle. Here a base may be polygon, but lateral surfaces are isosceles triangles. Where in the previous case all the regular mean every surface is same. So that's why those are regular. Since all the surfaces are not same, these are the irregular. So in this one you have to keep in mind the imaginary line which joins the center of the bottom part to center of the top. Bottom to top, the line connecting is known as the axis. Here, center of the base to the, note down here, this top portion is known as face. The bottom portion, whatever we are saying here, this is the base. Same here also, it is known as the base. Now coming to this imaginary line, this is known as the axis. This top corner point is known as apex. Next, these are known as the slant edges. These are known as long edges. Either this one or this one known as base edges. All the surfaces, these are known as the lateral surfaces. These surfaces are known as triangular surfaces. Here also lateral surfaces only. These are also known as lateral surfaces. But what the shape here? All the lateral surfaces are, in the case of prism, are rectangles. All the lateral surfaces in the case of the pyramids are isosceles triangles. Please, everyone has to keep this terminology, because to make you understand, you have to remember all these things. Clear? So which are the slant edge and which is the long edge and which is the base edge. Okay, it is known as the axis. It is known as the axis. The axis is equal to the height of the solid. Clear? So generally either the prisms or pyramids are specified side of the base and height of the object. Or height of the object is nothing but also known as the axis line. Clear? So also it is known as the axis line. The first case of the solids is a regular polyhedron. In the second case are the irregular polyhedrons. So of that we will test third one, solids by revolution. The name itself suggests how the solids are getting formed. Solids by. So in this case, what we mean, we will take a plane figure and we try to revolve about any one side as an axis about 360 degrees. So that imaginarily it tries to generate a certain value. So that value we have the specific name of the solid. Okay, for the simple to understand, let I am taking a plane of rectangle. If it is revolved about any vertical axis for 360 degrees, you are rotating about this vertical side as axis. So then it generates a certain value here, a certain value here. It tries to generate a certain value. This is nothing but cylinder. Similarly, if you have taken a right angle triangle and taken any perpendicular side as axis. Perpendicular side means either this one or this one, not the slant edge. As a edge for reference of the axis, if it is revolved for the 360 degrees, it makes a value. This value shape is generated is nothing but cone. Next, one more solid we are having by the revolution. If we are taken a semicircle and this diameter as the axis, if would have revolved for the 360 degrees, I can generate a value of sphere. Clear? So since all these three objects were generating by a plane considering revolving about any one of the imaginary axis for 360 degrees, the value generated leads to the generating a specific solid. So that's why these are known as the solids by revolution. If we are taking the plane, it leads to the cylinder formation. If we are taking the right angle triangle, it leads to a cone. If the semicircle area generates a sphere. The sphere is not that much important, but as subject point of view, these should be everyone known. Here also we are having the common terminology. So this bottom what we are having is known as the base. Same thing here, the top corner we are having the apex. Here top surface is known as the face. This is the complete lateral surface, this is the complete lateral surface. This side is known as long edge. This one is known as slant edge. In either the cases, this is known as the generator. Here also we are having the generator. So why is the name called the generator mean? If would have taken a circular base, if I kept the imaginary lines around the circumference of the circle side by side, what the total surface you are getting is nothing but cylindrical generation. So those are known as the leads to generate the surface. This also counts as the generator.